Okay, so I hope you all can see my screen. So we kind of somewhere there, like we should kind of start from here. Though I think 20 pages are remaining, but I don't think you have to kind of cover all of them because after a while they're all references. So I think technically we just have around 10 to 12 pages at max, and post that it is more about the references, right? So anybody want to kind of give any comments or anything before we kind of move forward? Any kind of thoughts you had while reading the chapter or anything like that?
Maybe just I find it difficult because this is for me just the first kind of paper I'm reading regarding artificial intelligence and
Mhm.
Kubernetes. So I hear you asking that question a lot of times. Do you guys have any feedback? And always sometimes there's quite some silence. So I just from my side, it's just reading it. I find it very interesting, but I find it a bit difficult to contribute yet.
No
So I'm
worries, no
working on
worries.
that.
So the idea why this paper came along, there was of course there's one challenge about that the book part which you're going to pick up next. But anyway, that's sorted out. So in between, this paper came from the KubeCon, and kind of we thought, okay, it would be better if we discuss it to kind of build a kind of um, groundwork for the next book what we want to pick up, right? So it's the new for all of us in a way. I'm also starting in the AI space though. So yeah, it's new for all of us, and whatever I understand, I am contributing, and same. I mean, whatever you have, um, your kind of knowledge, please feel free to add. That is all okay. So yeah, we saw it's all new for us. Nothing like nobody an expert. At least I am not. So now, what we pick up the book next, right? Machine learning on Kubernetes. That is where the real meat starts, like where we kind of dig deep and do hands-on there. But it's just like kind of building up, right? That cloud native and AI is coming together, and it holds, I believe, a very good future. So that is one thing. Um, One thing which I can add to it is I also joined the working group of the CNAI. So they do meet up and second and fourth Thursday every month. So today also there's a session they're going to have, and the discussion is happening to kind of extend this book further. And of course, whatever the discussion we had, they have taken some part of it and they're adding more details about the personas, when to use AI workload on Kubernetes, so on and so forth. So the inputs they have taken from the call in which they joined for the uh, first session we had, in which authors also joined. So there's work going on, and then I believe a lot of opportunities there to contribute. And it is also kind of what I from the last meeting what I have got from there. Right, there's still a lot of work needs to be done. The scope is still expanding on that. Right, so even the version 2 of this particular paper would have more details on that. But anyway, let's try to kind of go forward and try to see what this paper says so far, and then we'll go for the book next time. Okay, so this is the thing we're ready to start, which is path forward with cloud native AI, right? That is the thing which is there. So basically, this particular section talks about the approach and the initiatives to implement CNAI. So basically, um, the idea is, I believe, what approach cloud native is taking to kind of um, integrate with the AI in a better way, right? So and what kind of recommendations or actions need to be done by the this cloud native community per se, right? So one is flexibility. So providing the kind of say some kind of REST API interfaces through which we can easily kind of uh, perform different operations. For example, if I have to serve a model, right? So I should be having some kind of API calls through which that can be done. So some of that thing is coming. Sustainability is, of course, as one of the biggest what entire world is facing. That how we can bring in standardized methods and energy efficient methods to kind of do things in a better way. So, like again, kind of putting up some kind of tool, right, which basically tells you the accountability, like how much your workload is impacting the overall thing, right? For example, if you're just running GPUs unnecessarily, right, that may cause, of course, money and the power both together, right? So, how we can bring those things in a better way. That is the part which is mentioned here. Then we recommend ensuring that cloud native environments has the required GPU driver support acceleration for the workload. So of course, whenever the given organization, for example, NVIDIA releases the new library versions or new hardware, right? The implementation, the kind of addition of those in terms of the CN environment, like in the Kubernetes ecosystem that you want to bring in. Then this is one of the things which I kind of see is the missing part right now. That even though we know that cloud native and AI works together, but there are still a lot of stuff to be done before you get it working. So this can be solved by kind of getting some kind of reference implementations. So I believe you would have seen the documents from like Red Hat, right? They publishes the best guide or best way of doing certain things on OpenShift, for example, right? Similarly, different companies does that, right? So we need something similar for the CN environment as well, the CNAI environment, right? So how we can run the entire cloud native and AI stack together in an easier way. So we should kind of bring those kind of implementation details, right? That is the thing what has been mentioned here, and that is where kind of entire community looking towards. Then of course, the other part is as there are many moving parts, there are many different terminologies people uses. So how we can kind of come up with one kind of a say guideline or and say that one glossary of terms, right? That every one of us understands, right? So that is something which is kind of also part of the charter of the the CN and the CNAI per se. Those things would become clear as we kind of go forward. Um, Next is any comments on that, whatever we just discussed. Okay. Uh, Now, the next part here is evolving solutions on AI/ML. So, other than kind of going on this, I would kind of prefer to bring in this particular diagram here. Now, this talks about the cloud native project landscape, but it also includes something called as LFAI and data. So I assume that you know about Linux Foundation and CNCF, right? So what is the connection between them, right? So CNCF is, you can say, a child, or I would say that a kind of a say, yeah, you can say child, kind of say subsidiary of Linux Foundation, right? And Linux Foundation has more broader projects under its umbrella, and the CNCF uh, is now kind of trying to see that how we can leverage some of those LFAI and data projects. So if you are, let me bring in that site. Let me reshare my screen with a different tab here. Linux Foundation, LF, 1 minute. Let me reshare. So as you can see on the screen, right, this is what LF, AI and data projects under the Linux Foundation, right? So now this particular thing has a lot of projects as compared to the CNCF under the CNAI, correct? And as you can see there, the projects like whatever, like graduated incubation sandbox, there are many projects are already available under the LF AI and data. Now, what is happening and what I've heard from the previous keynote, what happened in this KubeCon, right? That they're trying to kind of bring in, not if not all, some of the projects from the LF data and AI under the CNAI umbrella. So that is also what is the work in progress. And what you see here, some of these projects which are mentioned here, it's a kind of combination of the under the CNCF and as well as the LF AI and data, correct? So so now what is required, right, to kind of do the entire AIML stack? So we talked about briefly of that those parts earlier in this particular book, right? That it's a combination of AI, machine learning, deep learning, and a data science, correct? So all of these things when come together, it makes the entire stack for the cloud native AI thing, right? And so like if you look at, right, data science, so this is under these products under that category, correct? Then we have architecture of our data that is again coming from these projects. So some of them, or actually most of them, are part of the CN or LFAI, but I may be wrong. Like for example, Apache may have under Apache Foundation, but a lot of these things fall under the LF and the CN Cloud Native and the LF foundation there, right? So of course I don't know about all of the projects per se what are being listed here, but if I just kind of categorize them, right, we can only do that, right? Like for example, while building the model, right? For building a model, you would require data. That is something can come from here. Then, of course, to build a model, you will require some way to build those models. Some tools is required. That those comes here, data science, correct? And then once you have the data, you would train to create a model, correct? That is kind of coming here. That you can use these tools to build the model. Now, once the model is being built, you would need to kind of serve those models. That is kind of coming here under ML serving. And of course, once you have, as you are serving the models, you would be also kind of, for serving the model, you require some kind of orchestration that is kind of mentioned here. So you can use these tools to serve these models, correct? And then to automate the process of uh, building the model, changing some parameters, by getting a new model, and so on. For that purpose, we have the CI/CD part here. These things would come under how do you regularly change your model and serve those models. And then you would require uh, observability and governance. That is what is mentioned here, right? And AutoML, I'm not too sure what does AutoML exactly means, but I'm assuming that it would be something to automate process, but I'm not sure. What is remaining here is observability. This kind of mentioned twice, I believe. So, okay, so this is observability of workloads